So we know from geometry that an angle consists of what's called the vertex of the angle and then two rays. So why don't you add little arrows on here? And so it's basically the rotation. If you take this ray, which is an endpoint, and then it goes on indefinitely, and you rotate it, then you get an angle. And this is the initial side, and this is the terminal side. So it's basically the rotation of a ray. A ray is like a segment, but one side goes on forever. Rotation of a ray about an endpoint. Okay, and that's the definition of an angle. So when we do a unit circle for trig, you have to know that you always start your angle along the x-axis and then you rotate in the counterclockwise direction. So you basically place your initial side of your angle along the x-axis and you rotate counterclockwise. So just remember, and this, I'm going to draw in this picture here for you. The coordinates, since this is an XY axis, the coordinates of this are the origin. So this is basically like 0, 0 on a coordinate plane. And you rotate around, and then like a point here, if you rotate, would have the coordinates negative XY because you're going to the left and up. So what you end up doing is you end up making these right triangles. This is why we've been studying right triangles. You drop a line, wherever your point is, let's say it's here, you drop a vertical line down to the x-axis, and that forms your right triangle. And then you can calculate the distance. This is always going to be in a unit circle. The length of this will be the radius of a circle, which will be length 1, and you can picture a circle all the way around the outside of this. So this is how right triangles are related to circular rotation, because you could define the location of this point by how far you rotated in this distance, or you could define it by the x and y coordinates, which is more of a rectangular motion instead of a circular motion. And don't worry about this side length being 1 right now. We'll come back to that. So just the concept, and then the quadrants are right here. Remember, this is quadrant 1. This is going to be really important. This is quadrant 2. We go around clockwise. Quadrant 3, quadrant 4. And so this just relates rotation to rectangular motion. And so just remember the vertex of the angle. Vertex of the angle is at the origin. Yeah.
I was wondering, like, for an angle that rotates 180 degrees, what would it wouldn't form a triangle?
Exactly. So when we rotate 180 degrees, it would just be a line. It wouldn't make a right triangle, but we can still do all the same things that we would with trig.
Yeah. And if the angle is at like 90 degrees, it would already be a right triangle.
Exactly. And if we rotate 90 degrees, it's actually not going to form a right angle either, and you'll see how we deal with that. It won't form a right triangle. Like if you rotated 90 degrees and you dropped the line down to the x-axis, it's just a straight line.
Oh. Okay.
Yeah. So actually, there's key points at 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360. At these places, I'm going to highlight them for you. So you're thinking really, really well. 0 degrees, 90 degrees, 180, and 270. You actually don't form a right triangle, and you'll see how we deal with that soon. Okay. So then when you rotate in this counterclockwise, that's a positive angle. So like, let's say if this is roughly drawn to scale, how many degrees do you think this might be? What would be reasonable? Well, 170 would be close to 180.
135.
Okay, so it could be, so just roughly that could be, and then if this is negative, it's almost in the middle. So what might be reasonable for this angle?
Negative.
Negative though, right? So yeah, negative 45 degrees. So the point of this picture is that when you rotate counterclockwise, those are positive angles. When you rotate in the clockwise direction, that would be a negative angle. And we don't need to write anything here. There's positive angles that way, negative angles that way. Yeah.
If the arrow was drawn on the opposite side, would that make it?
Yes. Positive. Yes.
Positive.
Yes.
300 and.
Correct. So
15.
yes. So now coterminal angles are angles that end in the same place. They have the same terminal side. So coterminal are angles with the same terminal side. So that'll help you make sense of the vocabulary. So here are examples of coterminal angles. Let's start with the simple one. 30 degrees. If you rotate counterclockwise, 30 degrees. Okay, we're starting there. The angles that are coterminal would be, if you rotate all the way past, all the way around once, that's 360, plus the 30, so that gives you 390. So it ends up the same place. So basically you treat 30 degrees and 390 degrees as the same angle because it ends up in the same place. And if you rotate it in the negative direction, it would be negative 330. So all three of these answers are really are coterminal. They all end up in the same place, so we treat them all the same. Those are coterminal. Okay, so let's try. Let's write a little example. One more example of coterminal. So let's say I tell you 10 degrees, and I want you to first give me the coterminal angle in the positive direction. What would that be?
370.
370, right? 360 plus 10. And then in the negative direction, how would you end up with at 10 degrees?
Negative 350.
So we'd go negative, we wouldn't go all the way around, we would go close to it, so negative 350, right? And those all end up at the same place. So those are coterminal angles. Okay, moving right along. Now a radian. Here's where we make a little conceptual leap. You're very familiar with degrees. You know there's 360 degrees in a circle. You know what 180 degrees looks like. But how can we say the same thing but in radians? So we need to think in terms of radians. A lot of formulas come out nicely if you use radians. In Trig, we always use radians because it's related to the radius. The word radian comes from radius. And let me draw you a picture of what it means. So let's say we have, just draw a little circle, and the length of the radius goes from the center here, that's R. Basically, an angle that's one radian, is if you take this length of the radius and you were to wrap it around the outside, so try to make it roughly the same, this angle is 1 radian. So literally, if you take the radius and you wrap it around the outside, this angle where the arc length is the same length as the radius is 1 radian. So then if we drew this around, that would be 2 radians, and this would be 3 radians. So, and then you can go around, and there's actually exactly in an entire circle, there's 6.28 radians, and I'll explain why in a second. And no matter how big your circle is, yes, it's equal to 2 pi. That's why. So there's actually, in a complete circle, if you rotate all the way around, there's 6.28 radians always, no matter how big your circle is. And that's because the circumference of a circle is equal to 2 pi r, which is 2 pi r, and that's pi is 3.14, right? So this is like 2 times 3.14 times r, or 6.28 r. So no matter how big your circle is, if you took the radius length, you would be able to wrap it around about 6.28 times. So now we're going to go around and label this circle in terms of the angles in terms of radians. Before we do that, I need to explain something here. The circumference of a circle is, and then we'll go back. We're going to add one definition here in a second, and we'll come back to it. Yes, question?
Yeah, I was wondering, so I'm a little confused by this. The 1 radian is equal to the same distance as the radius?
Yes.
Oh, okay.
Does the angle have anything to do with that? Like, is there a corresponding certain number?
Is the angle having to do with that?
If the radius is like 5 centimeters like that, what, like, is the angle always going to be like the same?
The arc length of 1 radian will be 5. Yes.
Like the angle of it.
The angle. Does the angle have anything to do with it?
Like, can you calculate?
You mean in degrees?
Yeah.
Yeah. There's a relationship always between the angle measurement in degrees and radians, and we're gonna get to that. There's a way to go back and forth, and that's important. So recall that the circumference of a circle is 2 pi r. And so now we have this thing called the unit circle, and it makes the measurements turn out nicely. And so we use it. And the unit circle, the radius is equal to 1, and that's why it's called a unit. And so therefore the circumference is just 2 pi. If the radius length is 1, then the circumference is exactly 2 pi. And so now we're going to fill in this whole unit circle with radians first, and then we'll go to degrees, and then you'll have both. So if you know, now here's where some fractions come in, but you'll get the hang of it. So if you know that all the way around is 2 pi, no. So we're going to start with radians only, and we're going to just divide this up. And if you have colored pencils, this would be a good idea.